This is Carla Petrie on a video regarding adhesion junctions. Adhesion junctions provide strong mechanical attachments between adjacent cells. They hold cardiac and epithelial cells together. They are a prerequisite for the assembly of tight junctions. Also, for a long time, these junctions were considered to be the key player for force transmission through intracellular junctions. Structure and various proteins involved. Adhesion junctions are built from cadherins, which is the red structure in the picture on the bottom left-hand corner. They are transmembrane protein whose extracellular segments bind to each other and also bind to the catenins. The catenins are the yellow structure that's attached to the cadherins. The yellow little ball structures. Those are connected to actin filaments, which is also on that structure, but you can't see. That's in black, so you can't really see that. Location is specific organism, and the role, it says adhesion junction use homophilic interactions of E-cadherins to bind epithelial cells to their neighbors, like in mature epithelia. There is a belt-like adhesion junction called zonula adherens. It encircles the cells near the apical surface. Is essential for viability from the earliest stages of animal embryonic development. Adhesion junctions also play an important role in vascular permeability control. They are located in cell-cell contact. They serve as a mediator of cell adhesions, and they transfer intracellular signals. A disease associated with the malfunction of adhesion junctions. So adhesion junctions are electron-dense transmembrane structures that associate the actin cytoskeleton with their absence. The formation of other cell-cell junctions is compromised. One of the cell-cell junctions that would be compromised would be the desmosomes, and a disease from this is called naxos. The first naturally occurring mutation from adhesion junction in plakoglobulin is Naxos disease. Since the desmosomes is a junction found mostly in the epidermis and the heart, this mutation is a recessively inherited disease. It is an arrhythmogenic right ventricular dysplasia cardiomyopathy, also the letters as ARVDC. Individuals with this disease may also have woolly hair and palm, can't pronounce that word, keratoderm, which is a thickening of the skin. And families with this disease originate from the Greek islands of Naxos, which is where the name of the disease came from. Also, evidence people with this disease also came from Turkey, Israel, and Saudi Arabia. And symptoms of the disease, a right heart failure, appear during the end stages of the disease. So it's a heart disease and a skin disease, and you have hair disease or curly hair. A recent finding about adhesion junction. A recent study examined how epithelial cells can regulate their mechanical behavior when cell-cell junctions are impaired. The study shed light on the role of epithelial cells that are part of confluent monolayer using a atomic force microscopy, which is a versatile tool and good to use with the adhesion junctions. Even though the molecular details of cell-to-cell junctions are well known, their role for cellular mechanics on the mole scale is largely unexplored. Adhesion junctions lead to reduced overall stiffness, but results with this in this study were reversible after reestablishing disulfide bridges and E-counter with DDT was removed, as you'll see in the next slide with this study. So DDT was used in the study to break the disulfide bridges because it's better to reproduce the DDT and suitable for selectively compromised functional adherence. So in the study, they used DDT in the adhesion junction of the cells for different things. So in the picture on the left-hand side, the study shows that they added DDT in the cell on B1, and then the fluorescence, you see it, and they let it sit for up to 3 hours, and then they removed it. So on B2, after 3 hours, there's no change. And then in slide B3, there's still no visible change of letting it sit after 3 hours of no DDT. But in the B4 slide, after 6 hours, it shows a total reversible change. B4 and B1 are back to the original same. So in the study, they tested other things, the tension. They studied the cell's height and the hardness and the softness, and throughout the study, it all went up and down. But after about 6 hours of no DDT, it all went back to the original size and shape. The cells recovered from the original state, and that's what they learned in the study about the adhesion junctions of the cells. Question is the adhesion junctions. If adhesion junctions are the prerequisite for the assembly of tight junctions, what would happen if the adhesion junctions were to break down?